The following animation depicts the sequence of events the CSB determined likely led to the accident. The propane deasphalting unit, or PDA, used high-pressure liquid propane to separate asphalt and gas oil from a heavy petroleum mixture known as pitch. Propane flowed through a control station, up a vertical pipe, and into an extraction tower. When the process was originally designed, propane also flowed through a second control station, mixed with pitch, and entered higher up on the same extraction tower. But in the early 1990s, the process was changed, and the use of this second station was discontinued by closing several valves. This created a dead leg, a section of piping without any flow through it. The CSB later determined that, unknown to operators at the time, a foreign object, a piece of metal, had wedged under the gate of one of the 10-inch valves, preventing the gate from closing fully and leaving a path for liquid to seep past the valve. The propane above the valve contained small amounts of water. Some of the water, which is heavier than propane, sank through the valve and accumulated in the piping elbow below.
The piping dead leg formed by the mixed control station had been left connected for years, apparently without incident. But now, in February 2007, conditions arose that would lead to a pipe failure.
That month, a cold snap dropped temperatures well below freezing for 4 days, reaching a low of 6 degrees Fahrenheit on February 15th. Water in the piping likely froze, expanded, and cracked the piping elbow. For a time, the ice itself prevented propane from escaping, until around 9 a.m. on February 16th, when the temperature climbed above the freezing mark and the ice began to thaw. At 2:09 p.m., the melting ice gave way. High-pressure liquid propane from the deasphalting unit began to escape through the small opening in the leaking valve and out the cracked elbow. The CSB estimated the initial flow rate of propane at 4,500 pounds per minute. A large flammable vapor cloud rapidly formed. The wind blew the propane cloud toward a boiler house. Moments later, the cloud ignited. Flames flashed back to the cracked piping elbow, creating a high-pressure jet fire. The fire rapidly damaged nearby pipes, causing a second jet fire aimed at a non-fireproofed steel support structure under a pipe bridge 77 feet away. Within minutes, it collapsed under the intense heat. This broke open numerous lines filled with flammable materials flowing from other parts of the refinery. The growing blaze threw massive fireballs and thick black smoke into the air. A surveillance camera captured the spreading fire. The alarm was activated at 2:10 p.m., a minute after workers heard what they described as a popping sound from the first propane release. The refinery's emergency response team attempted to turn on stationary firewater monitors, but shifting high winds hampered their efforts. 15 minutes after the fire erupted, managers ordered the total evacuation of the refinery. This decision may have saved lives, because the large extractors full of propane might have failed catastrophically, or the fire could have affected nearby units that contained other hazardous materials.